Hello, how's everybody doing? This is Norbert Monov, and this is our last lab, and this is CS 5549 Big Data App and Analytics Lab Assignment 4. Submission day is today at 12 o'clock. You can see it's not even 12 o'clock p.m. So let's see. First thing we had to do is Spark classification task. Use following data sets. From here, for database sets, we use the absolute set work. You can see here, this is the data set. You can just go folder. You see, you can download a folder, or then you can get information out of it. So for us, you can see, you see CVS. We have all the files, and we divide it by this. So you can see, so we import everything. So we put it. This is the file and CVS format and header and delimiter are this, and this our schema. You see, this is our big schema, and you can see from here that we use same schema for the decision tree. Like it's the same way to import data. You see random thing, we import in the same way for read. You see everything is loaded perfectly. So after that, we did the assembler because we need assemblers for this to work. So all the assemblers and all our data are same. You can see all the data are same. For assemblers, we turn off. For assemblers, we run all of those things. You can see like month, days, like that, but we didn't include the ID because if you do include ID, then it's gonna crash. You don't want to have those things. So, so our input color was features, and features the one we used. We everything on this thing we count as features. Just all the assembler things so we count as features. And the column we used for this is seasons because it was best accurate result we can get from. And then you can see here we used seasons like that. Then we use a splitter, and then we train the one, and other one was tasted and train selection, and we just indexed it by season features. You see this is the features, all these features, and then we just show the false. So let me run this. So while it runs, you can see we did get the navy base, and after that we did fit everything in it. And then after that we did the predictions, index feature prediction, everything like that. Only show 200 rows, and elevate multi-class evaluation. We did that and everything like that. Then we print the accuracy and errors in it. So this is the print from. Okay. So this is the first one. We did 200 shows right here. Everything is there showing. And then our predictions, which predicts everything, indexing. So everything showing like that. After that, at the end, we should show. Okay, you see our text accuracy was 49, 82, 57. So it's kind of bad, but it's not that bad for this dataset because this dataset is it's small, and Navy Base is meant for big data, like bigger data. So you can see a decision tree, everything's similar except we did the assembler and like input seasons. We put in all the things, and we created decision trees, and we create a pipeline, and from pipeline we fit it, and then we create model, and we just stick in the columns and features, so index features. So when we run it, we can see, come on. So it's running, running. you can see here we had only, because we tried to print out bad predictions, we had 108 bad predictions, and our text accuracy is not that bad. It's 0.8540. It's really good for this tree, and errors was 0.14. So uh, decision tree created uh, was in depth of 5 with 13 leaves. So it's kind of did good because this is meant for small datas, and it does it does accurate as possible. And then the last thing was we did the random forest. We had our inputs and everything like that, and we made sure that everything's loading, data assembler loading, and we did indexers, feature indexers, like everything like that, trains that are random split it, so everything's randomly. We use random forest classifier and everything like that. So after that, we did the um, pipeline fit training model and prediction model transfer test data. So you can see here everything. Uh, And then after that, we did the evaluation of multi-classification evaluation, accuracy, then we got the accuracy, and we did test error. And then we did the tree model, see how's this gonna work out. So when we run it, so you can see, so prediction selection, you can see here. So it predicts selections like to, damn it. You see prediction seasons and features, everything like that. And then after that, then you did the accuracy. So this is the accuracy, and this is test error, and this is the error result. This was the best result from it, and with this it created 10 trees. So everything like that it should be worked out. So and then when we go back to our thing, so you can see the state reason on why one algorithm performed the rest. The best one was the you can see that you can see that from our database the Navy Navy base was the mostly accurate because this is meant for bigger data and like that, and decision tree and random forest are made for like smaller data so they get better results. This both have like really close to the same result, but random forest has better result for it because it just created 10 trees and just gone through it, everything like that, so it has more accurate in there. So this is for the part one of our lab. So we answered the question A and C and B. Okay. Next. Okay. Okay. Then we use. Oh, we didn't do that. Then we did Spark streaming task. Okay. This is the last thing we did. This is the part two. You can see. I'm not gonna open my part two PyY because it has keys on it and I don't want to show it on YouTube. So I'm gonna open a speaker. So we got the speaker demo from the Lawrence. This is the person who created it, and we just run our code on top of this person's code. So this is the filter they created, and this is the things you needed to make sure that Twitter is running in part two, because this is gonna import everything in this ports, and then we have a listener in here. I'm gonna show you guys later on um, that there's a listeners listening this exact IP and port. And and then just text streaming. So then we create our word count. So this is our word count is right here. You can see it's kind of words, pairs counts, and then we print in the results. So I don't want to run in here. Some reason I'm having a problem with this computer, so I'm running on my different laptop, and we're gonna view it. So it's been running for a while. You can see here because I don't want to show the IP Twitter API keys we used. So these are sockets, it's listening, and we define everything here. Errors happens on data, what's going on with data, and then this is our send data, everything going on, custom key, custom secret key, access secret key. This is things you had to use your own because we're not gonna give you our secret keys. And so you can see here we're filtering data that equals Trump. So everything here, you see, everything to do with Trump. Trump is just tweeting crazy. Anything to do with Trump is just tracking it right now. It's because it's filtering the Trump. And so you can see here. So then we run the socket. So this means it's gonna run. I can show you my image here when I actually run it. Okay, you see when I actually run it, then it says listening on port 999. So that's gonna happen. And then after you run your speaker, it should popping this results. You see, good. It's news. Read news. Some crap. Just got this thread. Trump way right thread. You see all these things. It's just bunch of tweets. Just counting the. Okay, this is this was our so this was the part 2 of the lab, and part 3 we didn't do because it was optional. So that's it. Thank you very much for watching. Thank you.